Hi everyone, welcome to the third video of the system design series. In this video, we will talk about load balancer. Before understanding what a load balancer is, first let's understand why do we need it. There are many websites which has to serve millions of concurrent requests coming from thousands of users. The server might have to respond in terms of text, images, videos, or any other kind of data. And most importantly, everything has to be accurate. It's not possible for a single server to handle this kind of load. There has to be multiple servers in place to handle these many requests. In the last video, we talked about horizontal scaling, and we got to know how an application scales itself as the load increases or decreases. And we also got to know that this method needs a load balancer. Now let's assume we placed 10 high-capacity servers and a request comes. Who will decide to which server this request should be sent? This is exactly where a load balancer comes in. What is load balancing? So load balancing refers to efficiently distributing incoming traffic across a group of backend servers. So we have multiple servers placed at the backend. And what load balancing does, it distributes all the incoming requests among all the backend servers so that there is no load on one single server. And this group of backend servers can also be called a server farm or a server pool. There are several advantages of using load balancing. So it distributes client requests efficiently across all the servers. It ensures high availability and reliability by sending the request to only those servers which are currently active. And it also improves the flexibility as it allows adding or removing the servers on demand, like we talked about in horizontal scaling. Now let's understand the flow with the help of this diagram. Here we have several end users. In between we have the internet. Here we have the load balancer. So load balancer can either be a software load balancer or it can be a hardware load balancer. And in some cases, it can be a combination of both. And at the end, we have our application servers or the backend servers, which can also be referred to as server pools. Now, whenever the user opens a link, the request comes to this load balancer and the load balancer decides to which of these servers it has to send the request. Now, the server processes that request and sends the response back via the internet to the exact user from which the request came. So this is how the flow works. Next up, we have load balancing algorithms. So there are several algorithms through which a load balancing software decides to which server it should send the request. Let's go over them quickly. First is round robin. So it distributes all the incoming requests to the servers sequentially. Let's assume we have three servers, A, B, and C, and we have four requests at a particular instant. Now, request 1 is sent to server A, request 2 is sent to server B, request 3 is sent to server C. Now, the request 4 is again sent to server A. So it follows a sequence and it sequentially sends all the requests to all the available servers. Next is least connections. So in this method, the algorithm checks at that instant which of the servers have least number of connections and it simply forwards the request to that server. Pretty straightforward. Third is least response time. So in this algorithm, the load balancer calculates the average response time of each server and also the number of open connections each server has. It takes these two parameters and puts them into a formula and then determines the best route or the best server for our request and then forwards the request to that server. Fourth is IP hash. So this distributes the request based on a key that we define. That key can be either client's IP address or the request URL. So let's assume I tell the load balancer that whenever I am hitting request URL A, route all the traffics to server A. And whenever I am hitting request URL B, route all the traffics to server B. So the servers are segregated based on request URL or the client's IP address. And this method supports session persistence, which benefits applications that rely on user-specific stored information. So for example, if some user-specific information is stored on server A, for that user, all his requests should be sent to server A. So in that way, this method can be very useful. Also, one thing to note here is different load balancing applications or servers like Nginx, AWS load balancer, Cloudflare, etc. might have some additional ways of routing traffic like weighted round robin or weighted response time. But these are the basic. So what are the benefits of having a load balancer? First is reduced downtime. Companies with global presence and multiple locations in different time zones can benefit from load balancing, especially when it comes to server maintenance. For example, A company can shut down the server that needs maintenance and route traffic to some other available load balancer without causing interruption or any kind of downtime. So in that manner, a load balancer will help in reducing the downtime. Second method is scalable. So this is what we talked about in our last video, scalability. In case of horizontal scaling, whenever the traffic increases, we can dynamically add more servers, and a load balancer will start forwarding the request to the newly added servers. And that way, load balancer makes an application scalable. Third is improved security. Load balancers can add extra layer of security without requiring any additional changes or resources. So we can add various checks that will be done at the load balancing level itself, and we don't need any additional resource for that. So in that way also it is very helpful. Fourth is failure management. In case of any event failure, or let's say any of a server goes down, so load balancer can automatically detect that, and it can stop forwarding the request to the failed server or the down server. In that way, our application won't crash, and it will still be able to handle the requests. And the last one is efficiency. Like we discussed earlier, due to reduced burden of traffic on each server, the network traffic flows better and improves response time. So there is no load on one specific server, and the traffic is distributed equally amongst all the servers or based on one of the algorithms that we have chosen. So that way, it makes our servers efficient. This is all for this video. Thank you so much for watching.